Okay, we're going to continue our unit on graphing linear style functions, and we're going to build on the concepts that were introduced with the previous lesson on graphing real world problems, but now what we're going to do is take it into the abstract world of the coordinate plane. And so we're going to be able to sketch the graph of different types of equations, and that's the most of what we're going to do all throughout Algebra 2 is sketching graphs and analyzing graphs of all sorts of different equations. And so we're going to first learn about the method of graphing using a table of values. So we're going to investigate how do we use a table of values to graph anything. So the first thing we'll do is take a look at this first equation. We have 2x plus y equals -6. And we're going to have to figure out what does that graph look like. Okay, so we're going to figure out what does that graph look like, and then we're going to investigate how can we do that. So we have our equation, and we're going to use a table of values in order to figure out what that graph looks like. And so what in the world is a table of values? Well, a table of values is a table. It's an XY table. Now, what we remember from the previous lesson is that when we're dealing with x, y, remember how we read. We read it if x, then y. So we're going to build off of that knowledge. If x, then y. And then we're going to sketch the graph. And remember, what is a graph? A graph is the set of all ordered pairs that would make this a true statement. So we're going to look to see what are all the ordered pairs that makes this statement a true statement. And so how do we use a table of values? Well, we build off the knowledge. Remember, we're dealing with if x, then y. So what we can do is pick a few x values. We can choose a few x values. And so we can say, well, what if x was this? What if x was that? What if x was this? And then for each x, if x was this, what would y be? And so we can pick that ourselves. Now, my rules for choosing x values, I would like 2 of the values to be positive. I would like 2 of the values to be negative. And I would like 0 thrown in there somewhere. Okay, so 2 of the values to be positive, 2 of the values to be negative, and I would like 0 thrown in there somewhere. So that's what we can do. And in general, a general table of values that can incorporate these 2 negative values, like -2, -1, 0, 1, and 2. And those would be my if values. So if x was -2, what would y be? If x was -1, what would y be? If x was 0, what would y be? So on and so forth. And now what we're going to do is do a little math to figure those questions out. If x, then y. So if x was -2, look at this equation. What would y be? So we have 2x plus y equals -6. Well, if x was -2, we would have 2x plus y equals -6. So we create an equation that we would have to find out what would y be. So we have this y here. We're going to figure out, well, what is that going to be? And now what we use is all of our methods to solve equations. We can figure out what y would be. So first we crunch some numbers. 2 times -2, of course, is -4. And there's our plus y. And that would equal -6. And to find out what y is, we undo our -4 with a +4. And we find out y is going to be -2. So if x is -2, then y is also -2. And now what we're going to do is find out if x was -1, what would y be? So we're going to do that. We're going to write the equation again. 2x plus y equals -6. 2x plus y equals -6. And we're going to figure out what y would be. 2 times -1 is -2. So -2 plus y equals -6. Now we're going to solve for y by adding 2 on both sides. And we find out y will equal -4. So if x is negative 1, then y is negative 4. We're going to do the same thing for 0. So we have 2x plus y equals negative 6. So 2x plus y equals negative 6. 2 times 0 is 0. And 0 plus y equals negative 6, so y is negative 6. So if x was 0, y would be negative 6. And if x was 1, we crunch our numbers. You do the same process. If x was 1, you will see y is going to equal negative 8. And then you plug in the same thing. If x was 2, crunch your numbers. If x is 2, then y will equal negative 10. So we have our table of values. Okay. Now, what we need to know about a table of values. A table of values gives us sets of ordered pairs. A table of values gives us sets of ordered pairs. Right? So we have if x is negative 2, then y is negative 2. If x is negative 1, y is negative 4. If x is 0, y is negative 6. Those are all ordered pairs. So what we can do is graph these ordered pairs. So we can set up our coordinate plane. And then we're going to graph each of those ordered pairs. So we'll start with our first ordered pair. If x is negative 2, y is negative 2. And we'll graph that ordered pair. If x is negative 2, then y is negative 2. There's that ordered pair. If x is negative 1, then y is negative 4. If x is negative 1, then y is negative 4. If x is 0, then y is negative 6. If x is 1, then y is negative 8. And if x is 2, y is negative 10. It will go down 2 more times. And so we have the ordered pairs that we created from our table of values, and we notice what is happening with this graph. So this graph looks like it's going to make a straight line, and it's going to continue moving in this direction. But remember, what is a graph? A graph is the set of all ordered pairs that would make the equation true. So the set of all ordered pairs that makes the equation true is every single ordered pair on that line. And so what we can do is draw our line all the way through those ordered pairs to show continuity, and we have now sketched the graph. Now there's our sketch. We've used a set of ordered pairs. Now what I want to do is link this back real quick to previous knowledge from the last unit. Remember on the last unit, if we had an equation that looked like this, and I asked you to find the x-intercept and the y-intercept, okay? Remember how I asked that question. The x-intercept is when y equaled 0, and the x-intercept in this case would be negative 3. And we found the y-intercept of that equation, and the y-intercept is when x is 0. And we will find that our y-intercept is negative 6. Remember what we did in that last unit, and well, take a look at our graph. Does that match up with the information that we found in that graph? We found the x-intercept to be negative 3. Look at the graph. Where's the x-intercept? Negative 3. We found the y-intercept to be negative 6. Look at the graph. The y-intercept is negative 6. So it all checks out with what we have done in the past. So we can sketch our graph and we can relate prior information. So now let's take a look at number 2. Now we're going to sketch the graph of this equation. And again, we're going to use a table of values. Okay, so we have our equation y equals 1/2 x minus 2, and we're going to use a table of values, our x, y chart. Now remember, we're dealing with if x, then y. And because we're dealing with if x, then y, we can choose the x values we want to choose. But remember what I said, I want 2 positive values, 2 negative values, and 0. So for this, can we pick -2, -1, 0, 1, and 2? Yes, we can. We certainly can. But I'm not going to. There is a smart way to approach this if you think. Take a look at what's happening to the x in the equation. The x will eventually be divided by 2. Because of that fraction, the x will eventually be divided by 2. So when I pick my x values, I want to pick values that are divisible by 2. And remember, I want 2 negative values. I want 0, and I want 2 positive values. So I'm going to smartly pick x values that can be divisible by 2. That's a smart move. And then we're going to do the same thing. We're going to crunch numbers to figure out what would y be. So we're going to rewrite our equation. Y equals 1/2 x, and x in this case is going to be -4, 1/2 x minus 2. So we're going to substitute our if x is -4, what will we get for y? So we crunch some numbers. Now we have 1/2 times -4. Whichever way you work this out, looking at multiplying top times top and then bottom times bottom, or how you're going to, whichever way you're going to work this out, you know 1/2 of -4 is going to give you -2. And then we have our minus 2 at the end. And so we have y would be equal to -2 minus 2, and that of course is -4. And then we have the second x value, our original equation. Y equals 1/2 x, 1/2 x minus 2, and we're going to find out what y would be. And so we're going to crunch some numbers. And so y is equal to 1/2 times -2. Whichever way you're going to work that out, you will get -1. And then you have -1 minus 2. And of course, -1 minus 2 is -3. So if x is -2, y is -3. We'll do the same thing for 0. Y equals 1/2 x minus 2. And then we find y will be equal to -2. We do the same thing for positive 2. We'll find out y is equal to -1. We do the same thing for x is equal to 4. And we find out y is going to be 0. So we have our table of values. We have our table of values. And what we're going to do with that table of values is graph them. Remember, the table of values gives us the ordered pairs. And so we make our coordinate plane, and we can draw our marks. And then graph each ordered pair. So our first ordered pair, if x is -4, y is -4. If x is -4, then y is -4. There's our ordered pair. If x is -2, then y is -3. We draw our ordered pair. If x is 0, y is -2. If x is 2, y is -1. If x is 4, y is 0. And notice what's happening. Again, it's a similar pattern is emerging. It looks like this thing is going to make a straight line. Interesting. So we will make our straight line. Remember, what is the graph? The set of all ordered pairs. Not just these ordered pairs, the set of every single ordered pair that would make that equation true. And so we draw our line to represent continuity because it's the set of all ordered pairs that would make the equation true. There is our line. So we have sketched the graph of the equation using a table of values. So one thing I want you to pay attention to, notice for each equation that we had, our first equation was 2x plus y equals -6. Our second equation was y equals 1/2 x minus 2. Both of those equations, the graphs were straight lines. That's interesting. We'll keep note of that as we move through the unit. Thank you.